So chemistry, this is for 3.1 and 3.2. So what should have happened before you're watching this video is you should have read 3.1 and 2. Probably taken some notes, done some studying, taken the quiz that I already gave you, and now you're here at this moment getting ready to grade the quiz that you just took. So if you have not yet taken the quiz, pause the video, go do those things I just described, and come back and pick this up later, because I'm about to hit up what the quiz answers are. So here's quiz answers. 1 is physical states. 2 is homogeneous, H-O-M-O-G-E-N-O-U-S. It doesn't have to be spelled perfectly, but it should look like homogeneous. It would have to start with homo, and then if you get genius a little bit goofy, then so be it. 3 is heterogeneous, H-E-T-E-R-O-G-E-N-E-O-U-S. Same thing, it has to start with hetero, and then if you misspell genius, life goes on. Mixture is the other one for 4. Doesn't matter, 3 and 4, which one's in which blank. If you have something you're not sure how to score, right now while it's fresh on your mind, put a question mark by it so that you don't have to remember later what your scoring questions were. Just throw a question out there now. 5 to 7, we're doing 3 category names, and it doesn't matter what order you put these in. 1 is a homogeneous mixture, which is going to be the first sort of conflict, difficult to keep straight memory thing of this chapter. That mixture was used at number 4 for heterogeneous, but now they're doing a thing called a homogeneous mixture. I didn't invent chemistry. Blame Lavoisier or somebody else. I don't know who came up with this name game system, but I'm not a huge fan of. Mixture was a synonym for heterogeneous in 3, but now related to number 2, there's a thing called a homogeneous mixture. I don't know. So mixture versus homogeneous mixture, not the same thing at all. Opposites, in fact. Solution is another part of 5 through 7. A pure substance is another part of 5 through 7. So one more time on those. Homogeneous mixture before I went on my rant. Solution and pure substance. 8 is compound. 9 is element. 10 is atom. And that helps you do a score in a quick way. So here's some notes that I have on my paper that it's good to probably throw these notes on your paper because they'll appear someday eventually, and then I'll give you an exact description of what the quiz looks like for 3.3. For number 1, physical states, there is actually a 4th physical state possible, which is a thing called plasma. The book's not big on plasma. The physics book mentioned plasma some. Plasma's like outer spacey, on the sun, out there kind of stuff. So throw plasma on there as a 4th category. I don't know if that'll make the quiz or that's just a discussion. Beside the solid, liquid, gas, I made a note to myself that whether something is a solid, liquid, or gas depends on the pressure and the temperature and the molecular properties. So solid versus liquid versus gas depends on the pressure, the temperature, and the molecular properties. I also have a note to myself that not all matter exists in all 3 states. Some do. For example, water. If we play around with the temperature of water, it gets too cold, you get a solid. It gets too hot, you get a gas. Steam, water, ice, it's all the same H2O stuff. It just depends on the temperature involved. It also depends on the pressure. If you do affect the pressure, things can freeze at temperatures other than 32 or 0, depending on your temperature scale. Water can boil at temperatures other than 100 and 212, depending on your temperature scale, if you mess around with the pressure. So whether something's a solid, liquid, or gas depends on the pressure, the temperature, and also molecular properties. But not everything does exist in all 3 states. For example, sugar. If you ever take sugar, which is a solid, and you try to heat it up, and melt it, it won't melt. It does a thing called caramelize. It changes into caramel. It's not going to become like melted sugar. It's just not a thing. So not everything exists in all 3 states, but what the state depends on is the pressure, the temperature, and the molecular properties. Homogeneous in 2 words means it's the same throughout. Homogeneous, we'll have some offshoots there in number 5 to 7, so we'll talk about that in a little bit. Heterogeneous is not the same throughout, and that is called a mixture. So mixture is a synonym for heterogeneous. Mixture and heterogeneous are antonyms for homogeneous. So I have a little chart behind me. I'll fill in as we go. Matter is what everything is made of. Everything in the universe is made of matter. Matter, all items that are made of matter can be separated into one of 2 main categories. Homogeneous versus heterogeneous. So this particular item, you could ask yourself, and pause if you want think time, you know, this item that I'm holding up for you right now, is this homogeneous or heterogeneous? And the answer is, this is heterogeneous. This is made of 2 different things. Look, those are different, 2 parts, right? Now this item that I'm holding up, is this hetero or homogeneous? This is homogeneous. This chalk is the same throughout. Other examples. If I wanted to grab myself this item. What is this item? Well, this is definitely heterogeneous. There's at least like 4 different things going on here. There's the clear plastic is not the same thing as the lid, which is not the same thing as this paper label, which is not the same thing as the water inside. Okay, that is absolutely heterogeneous. If I grab this item, doesn't want to come off. If I pull off this ring, I can pull off the label. Okay? If I went like this, I would have tricked you and you might have said homogeneous. It's actually still heterogeneous because this ring that surrounds the bottle top is not the same as the rest of the bottle. If I could pull this off, which I could, but I'm feeling lazy right now and I need something to pry that off with. If I pulled the ring off, now we're back to homogeneous because this would have been the same throughout. Next group of 3. Homogeneous can get subdivided into 3 other options. There's a thing called a homogeneous mixture, which is the complete opposite of a plain old mixture. Okay, so this I could call a mixture. It's made of mix of 2 things. You know, the chairs in our room are mixtures. They're made up of the seat part and the bars and stuff that support the seat part. But a homogeneous mixture, the only thing I can really give you that's a very good example of a homogeneous mixture would be like air. The air that fills our room is a homogeneous mixture. It's made up of oxygen and carbon dioxide and nitrogen and all sorts of things. But the air in this room, it's the same throughout the room. Homogeneous mixture would be pretty much just air, for an example. Definition for a homogeneous mixture is that it's 2 or more pure substances whose proportions can be varied without limit. 2 or more pure substances whose proportions can be varied without limit. In other words, like the air in our room, if we added in a little bit more oxygen, added in a little bit more CO2, added in a little bit more nitrogen, it would still be air in the room. Like without limit, we could mix those gases and they're mixable. That's a homogeneous mixture. Second option in this is a solution. An example of a solution would be almost anything that you've ever dissolved in liquid, like Kool-Aid is a solution, Pepsi is a solution, Gatorade, most of those drinkable type things. The definition for a solution is that it's 2 or more pure substances whose proportions can be varied within limits. Okay, if you have Kool-Aid mixing experience, I think you'd realize there's limits to what you do with mixing your own Kool-Aid. You usually use a lot of water, a little bit of powder, and a medium amount of sugar. Okay, you couldn't mix Kool-Aid with a whole 5-pound bag of sugar and like a drop of water. That wouldn't make a solution. That would make a mess. There's limits to what you could do there. And then the third category off of this was a pure substance. A pure substance is basically anything with a chemical formula. Okay, so gold, water, H2O in other words. The definition for pure substance is no variation of proportion. You have no wiggle room. Okay? Kool-Aid is a solution. You have a little bit of wiggle room. If you want a little more sugar, a little less water, a little more water, a little more flavor packet, you know, you have an ability to have some variation of what you're putting together. A pure substance you don't. Like water is H2O. At like an atom level, for every one oxygen, you need 2 hydrogens. You can't be like, well, I feel like my water being H3O. Well, no, H3O is not water. There's no wiggle room on H2O for water. There's some wiggle room for putting in a little more sugar in your Kool-Aid. There's complete wiggle room for if you want to put some more oxygen in the air. There's no problem with that. That's unlimited. Okay? All of those are homogeneous though. Water is water. It's the same throughout. Kool-Aid is Kool-Aid. It's the same throughout. Air is the same throughout. All of those are homogeneous. They're all the same throughout. Air was a homogeneous mixture because there's no limit to how much of any one item you can put in there. Solutions like Kool-Aid are called solutions because there's a limit to how much of each item you can put in there. Pure substances, you have no variation possible. It's just H2O. Heterogeneous, also called basic mixtures, are just totally different things. That's chairs and chalk holders and whatever you want to look at. Then pure substances we can break down into another two-way category. For pure substances, there are elements. An element is anything on the periodic table. And there's also compounds. Compounds are made out of more than one element. So on my paper here for compound, number 8 definition, I drew a box around pure substance, can be broken down, and simpler substances. So for number 8, that's going to be our key phrases moving forward. A compound is a pure substance, which means it has no variation, which means it is the same throughout, which means it is made of matter. You can sort of follow the chart through. If you're in one category, it's in all the categories linked above it. But compounds are a pure substance that can be broken down into simpler substances, like CO2 is a compound. CO2 could be broken down into carbon and oxygen. It's a pure substance because it's a set formula. It can't be CO2.5. Like it's just CO2 is CO2. It's got to have one carbon for every 2 oxygens. But it could be broken down into its pieces. Elements, for number 9, I drew a box around pure substance that cannot be broken down. And I wrote a note beside number 9. There's 111 elements at the writing of our book. There's probably more by now, I don't know. You could Google that if you care, if they found some more elements. If they do enough bombarding of particles off of things in those super colliders and stuff, sometimes new elements are created or discovered. But there's 90 that are naturally occurring, and then the other 21 were man-made, at least as of the writing of this book. So that's worth maybe a jot down. 111 elements now, 90 of them are naturally occurring, like oxygen is naturally occurring. Some of the other ones that are getting up there on the periodic table, our book had 2 that aren't even named. Elements 110 and 111 were discovered, but not even named at the time of the writing of our book, whenever that happened. Atoms, I drew a box around for atoms, from the word still to the end. It's the smallest piece of an element that can exist and still show the properties of that element. So if you go smaller, 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 but you can still tell that it's gold, that's an atom. If you break it up, an atom, to a point where you can't even tell it's gold anymore, smaller than an atom, you have protons, neutrons, and electrons. So if you cut up the nucleus and out falls a bunch of protons and neutrons and there's loose electrons and you don't even know what it is anymore now, that's no longer an atom. But the atom is as small as you can go and still show the properties of the element that it was, be it gold or whatever. So again, elements, anything that's on the periodic table, and they're made of atoms. Compounds, anything that has a chemical formula, sugars and salts and acids and water and CO2 and all those things. Those are all compounds. So let's take a look at next quiz up. So, and homework. Homework, you could go 1, A through J, and you could do problems 3 to 5. Problems 3 to 5 are going to be classifying matter to some degree, whether something, number 3 wants you to list whether it's a solid, liquid, or gas. So if they say to you, like Kool-Aid, you'd say liquid. If they said your chair, you'd say solid. If they said oxygen, you'd say gas. Number 4, they have you looking up in the book where they're listed the 10 most abundant chemicals in the Earth's crust. So that's not like in the Earth, like what you're breathing. They mean like start digging in the ground and what's the Earth made out of in terms of the crust. They want you to list those. Those are found in the book. And then they'll play a game that I'll play with you in a second, asking you to decide whether something is an element, a compound, a mixture, of what it is on this table. But, so that's the homework. The quiz next time up is a 3-3 read. 3-3 read is only going to have 3 new points. So what you should be studying from is from reading 3-3, not doing peeksies at the 3-3 quiz. That'd be a type of cheating. I know you have the quiz. I'm trusting you not to do quiz peeks until you're actually sitting down to take the quiz. It's not worth sinning over 3 points. Just do your best to read in 3-3, come up with the notes for the 3 points. If you guess wrong, you guess wrong, but don't sin and cheat over 3. That's dumb. Question 1 from today will stay the same. Question 2 is going to go backward. What is homogeneous? And you can say same throughout. Question 3 will change to what is heterogeneous? And you'd say not the same throughout. Question 4 will be changed into what's another name for heterogeneous matter, and you would say just the one-word mixture. When you just use the one-word mixture. One-word mixture is a synonym for heterogeneous, which is the opposite of all this other stuff. Then there's a 9-point question instead of 5 through 7. Okay, so it'll say to do a name, to do a definition, and to give an example of the 3 categories of homogeneous matter. So you'd say homogeneous mixture is made of 2 or more pure substances whose proportions can be varied without limit. For example, air. Solution, you'd say the same thing but within certain limits. And the example there would be, Kool-Aid or something like that. Pure substance, you'd say no variation of proportion, and those examples are like H2O or CO2 or sugar, salt, acid, that kind of stuff. 8 will go backward. What's a compound? You'd say pure substance that can be broken down into 2 or more simpler substances. 9 will go backward. What is an element? You'd just say it can't. Same concept, but can't be broken down. And then 10 goes backward. What's an atom? You'd say it's the smallest piece of an element that can exist and still show the properties of that element. Playing a game like the homework. I have a sheet here where it's asking to classify in which category this is. So I'll say them. If you want to play along at home, you could write down what I'm saying, pause the video, and then you try to decide what they are. But I'm going to run through what type of thing is it. Concrete, selenium, formaldehyde, aluminum, brass, hydrogen sulfide, apple, and a soft drink. So if you didn't catch that, just rewind it. So if we go looking through that list for mixtures or heterogeneous stuff. Mixtures, heterogeneous stuff, I would go with an apple because it has the seeds, it has the fruit, it has the peel, it has multiple different things. It's not the same throughout. And I'd go with concrete. I don't know if you've ever seen concrete like all broken up, but it's not the same throughout. Concrete isn't like that. Asphalt, I think, is. Asphalt is maybe the same throughout, maybe not. But concrete, if you ever see concrete get broken up, it has like big rocky bulbous things inside there. It's just not the same throughout the whole thing. Everything else would have gone in the homogeneous category, but that doesn't make homogeneous the best answer because these things are better answers than homogeneous. So if we go down the chain, homogeneous mixture, you come out with a shutout on that because the only example of homogeneous mixture I can really give you is air. Solutions, the ones that were solutions would be soft drinks like Kool-Aid, Pepsi, that Gatorade, all that kind of stuff. But also brass. I don't remember if the book had said this or not, but some solutions, not all solutions have to be things mixed in water. The most famous example of that is brass. Brass is a solution of two different kinds of metals, which seems weird, but it can be done. Most solutions are things dissolved in water, but brass is a one-of-a-kind sort of thing. Pure substances, the other ones that are left would be pure substances, but pure substance is never the best answer because pure substance can be broken down into elements or compounds. Elements are anything on the periodic table. And I realize you haven't memorized the periodic table. But inside the front cover of your book, there's a periodic table. And there's also a list of every element alphabetically on the periodic table. Elements from what I gave you would include selenium and aluminum. You would have heard of aluminum. You might not have ever heard of selenium. I don't know. But selenium and aluminum are both elements because they're on the periodic table. And then that leaves us compounds. The other stuff we have is compounds. Hydrogen sulfide, that's a thing like a CO2, carbon dioxide, that'll have a formula. We'll worry about writing those later in the year. But hydrogen sulfide would be a compound. Formaldehyde is another thing. It would have a chemical formula. I have no idea what that is. But formaldehyde, that's like the stinky stuff that is like when you go to do your dissections and you pull the dead animal out of something. That's formaldehyde, but formaldehyde would be an example of a compound. It has different substances in it, and it would have a chemical formula. If that went great, then great. If that went badly, I have another paper where we have ability to play the same game again. So if you want an instant replay, play it again. Here's instant replay, play it again. So what we have here I have a group of 10 things. If you want to write them down, play along with me. Options are antimony, paint, blood, red wine, hydrogen peroxide, neon, an orange, the fruit, a Mountain Dew, a T-bone steak, and Epsom salts. You might not even know what all of those things are. Then that makes it harder to answer those questions. But if you play that game, and look for mixtures. Mixtures are made of two or more things. So mixture, synonym is heterogeneous. That would be the T-bone steak, because that has fat, meat, and bones in it. An orange, because that has the rind, and then the fruit, and then some of that weird white stuff that you sort of want to peel the skin off, or maybe you like to eat the skin, I don't know. Blood is made up of different things. platelets and the cells themselves and different. I'm not a biologist, so I'm not sure. I just know blood is not made up of only one thing. It's not the same throughout. Paint is definitely not the same throughout. If you've ever opened up a can of paint that hasn't been open for a while, it like all separates out. You know, if you want to use paint, the first thing you have to do is like throw it in one of those crazy mixers at the hardware store, probably, to get it mixed together to make it temporarily the same throughout, but it really isn't the same throughout in a permanent sort of way when you're dealing with paint. Again, homogeneous is never the best answer because we branch off into 3 categories. Homogeneous mixture, I'm shut out again as always because air is the only thing I can give you. Solutions here would be red wine and Mountain Dew. Those are the same throughout, and again, stuff that's dissolved in water pretty much is solutions, with brass is the previous exception. Pure substance would never be the best answer because we're going to always recategorize every pure substance as either an element or a compound. Elements on the periodic table would be neon and antimony. And again, use your reference tools in your book to look those up if you have to, which makes the compounds Epsom salts, which have a formula that I forget. But again, compounds like salts and acids and things like that, sugars, those are all compounds. And then hydrogen peroxide is like a chemical formula kind of thing for sure when they start naming elements like hydrogens and oxides and things. That's in that column. So hope that helps. Email if you have any questions or want to Zoom about any of this.